Well, let's finish up math this week. It's been a challenging week. I know it's been a bit hard, you might say. Some of you might think it's hard. Some of you maybe think it's not so hard. I think this is one of the harder things we've done, harder weeks we've had with math. I hope you're getting it. We have to move pretty fast, pretty quickly through this, according to our pacing guide in Hamilton County. So we'll go back and review it all, but we've got to keep moving on. Today, I've got this here. My little circles are messed up again like they were the other day, but we'll write them out. So today we're still comparing fractions, as you saw in Mr. Walker's video. And today we're thinking about the size of the pieces that would be in a drawing of the fraction as we look at these. He talked about the numerator a lot in his lesson. So the numerator on these three we see right here, they're all the same. You have 1/4 and 1/5, or 3/4 and 3/5, or 1/10 and 1/12. So we got 1 and 1, 3 and 3, 1 and 1. So they're the same on these first three. So what we're really looking at is which piece is bigger. Would a candy bar divided into 4 pieces, would each piece be bigger? Or a candy bar divided into 5 pieces, would each piece be bigger? Well, hopefully you know by now that a fourth is a bigger size than a fifth, because that same candy bar, if it's the same size, if you split it into 5 pieces, each piece is going to be smaller than if you only have to split it between 4 people, right? So that's what we're thinking today is on this first part. So as we look at these, we're looking at 1/4, and these are written out in words, it doesn't matter, and 1/5. I think it's just I want you to think about the denominator, okay? When we see numbers, what we want to do, our mind wants to go, 1/5 is bigger because 5 is bigger than 4. Be careful not to do that on your assignment today, because a bigger number on the bottom means there's smaller pieces. So if we have the same number on the top, the bigger number on the bottom is going to be the smaller one because the pieces are smaller. So thinking again about a candy bar, if you divided it into 4 pieces or 5 pieces, and you want to get as much as you can, you want to get the 1/4 of a candy bar instead of 1/5, because you get a bigger piece. 1/4 is bigger than 1/5. Same thing on this one. Same candy bar. We've still got it split into 4ths and 5ths. Do you want 3 out of 4 pieces or 3 out of 5 pieces? Well, if you get 3 out of 4 pieces, you get the most, right? 3/4 is greater than 3/5. Third part, 1/10 and 1/12. All right, we just have to think. You've got to train your brain today to think. If the number on the bottom is larger, that means it's smaller pieces. So if the number on the top is same, 1/12 is going to be a smaller piece than 1/10. That means 1/10 is greater than 1/12. And so that's going to be the first part of your assignment today. That's how they are going to look on the first part of your assignment. There's quite a few problems today. I'll just go ahead and tell you. I think there's 20, maybe 25. I forget. The second page here of my examples for you got 7 and 7. So we've got 7/10, 7/12. Just remember, the bigger the number on the bottom, the smaller the pieces are. You got 12 little pieces compared to 10 pieces. So 7/10 is going to be greater than 7/12. So it's pretty easy when you got the same number on the top. And we're going to get into some now that some of them have the same number on the top and some of them don't. So this one right here is 3/5 and 3/4. It's kind of like the first part there that we did a minute ago. Fifths are smaller. So if we split a candy bar into 4 or 5 pieces, we know that pieces split into 4 parts. The candy bar split into 4 parts has bigger pieces. So 3/4 is bigger. We had the same number on the top. It makes it easy. But what about this one? 2/5 and 4/9. What are we going to do with this? Here's what I like to do. We're supposed to use reasoning on this. Compare by reasoning about the following pairs of fractions or same related numerators, it says. So, we've got ninths and fifths. So we know that ninths are smaller pieces, but I've got 4 ninths. And I've only got 2 fifths. So it's impossible to really just look at these two numbers and without drawing it or without having some kind of strategy to know which one's bigger. But what can we do? How can we solve this? Well, if I can get this 2 to be a 4, then I can have the same number on top, right? Well, how do I make a 2 a 4? I multiply it times 2. And I've got to do both top and bottom times 2. So 2 times 2 is 4. 5 times 2 is 10. Well, now it's much easier to see. So 10 means there's smaller pieces. So 9 pieces are larger. These 9 pieces are larger than these 10 pieces. And if we get 4 of each of them, then we know my allergies are crazy today. We know that if I'm comparing 4/10 and 4/9 now, it's easier to see that 4/9 is bigger. Remember, you got to train your brain. These bigger the number on the bottom, the smaller the pieces. So 4/10 is less than 4/9. So on these problems, try to get the same number on the top, and that makes it much easier to compare. Well, on part C here, we've got the same number on the top. That makes it nice and easy. 7/11. And I'm not going to rewrite all these. These circles, they're just not, they're supposed to be in the middle of the two, but when it printed, it messed it up somehow. So 7/11 or 7/13. Which one's going to be greater? Remember, the bigger the number on the bottom, the smaller the pieces. So 7/11 would be greater than 7/13. Now, this one right here, part D, we do not have the same number on the top. So, but I can make a 6 a 12, can't I? How can I make a 6 a 12? Well, I'll multiply it times 2. So let's do our multiplication like we've been doing for a couple weeks. 6 times 2 is 12. 7 times 2 is 14. So now, I've got 12/14 and 12/15. We know that 15, since 15 is bigger than 14, these are smaller pieces. So if we got the same number of them, then 12/14 is going to be greater than 12/15. That's backwards thinking. I know, guys. Some of you are going, I don't get it. 15 is bigger than 14. Just remember, if we split a candy bar into 15 pieces, those pieces would be smaller than if we only split it into 14 pieces. That's why this is bigger. Okay. Number 3 here, it says to draw 2 tape diagrams. We can do that. We can model them. We can do what we're doing. I'm just going to keep doing what we're doing. I think that's the easiest thing to do, okay? So on this one, we can't make a 2 a 5, but can we make a 3 a 6 and compare them? Sure. So what do we do to make a 3 a 6? We multiply it 3 times. Oh, sorry, I put that on the wrong side, didn't I? 3 times 2 is 6. 2 times 2 is 4. So now it's easy to see 2/3 is the same as 4/6, which that would be smaller than 5/6. Okay. Let's keep moving on. Got a lot to work through today. The next one is kind of similar to that. I can't make a 3 a 7, but I can make this 4 an 8 really easily, can't I? How can I make a 4 a 8? I've got to multiply it by 2. So 4 times 2 is 8. 3 times 2 is 6. Just always remember, whatever you multiply by on the bottom, you multiply by on the top. So I've got now 3/4 is an equivalent to fraction to 6/8. So now it's easy to see 6/8 and 7/8. 7/8 is greater than 6/8. All right, so now part C throws in some mixed numbers. Oh my. Well, 1 3/4 and 1 7/12. Let's just forget about the ones for a minute, and let's just say this was 3/4 and 7/12. I can't make a 3 a 7, but I can make a 4 a 12, can't I? How can I make a 4 a 12? I've got to multiply it times 3. So 4 times 3 is 12. 3 times 3 is 9. So I've got 1 9/12. And 1 7/12 is what we have. So that makes it easy to see. 9/12 is bigger than 7/12. So that means 1 3/4 is greater than 1 7/12. Okay, moving right on, right along now. Compare the fractions below. We're just doing the same thing. You can draw one number line to model each pair of fractions with related denominators. If you want to draw them on a number line, do it. If you want to do tape diagrams, do it. If you like doing what we're doing right now, then just keep doing what we're doing right now. As long as you can find that answer today, use whatever strategy helps you best. I just think it's easier just to find either the same number on top or bottom. So I can't make a 2 a 5, but I can make a 3 a 6. So I multiply it by 2 to make a 3 a 6. So we got 3 times 2 is 6. 2 times 2 is 4. So an equivalent fraction to 2/3 is 4/6. And over here we've got 5/6. So obviously 5/6 is greater than 4/6. You getting it? I think this is not that hard. It's not that bad, I don't think, today. We just got to make sure we got the same number either on the top or bottom. Can I make a 1 a 3? Yeah, how do I do that? Well, we can make it multiply it times 3. So if we do that, then we've got 1 times 3 is 3. 4 times 3 is 12. So 3/8 or 3/12. Which one's bigger? Well, remember, the bigger the number is on the bottom, the smaller the pieces. So 3/8 is bigger than 3/12. Could we have done that one a different way? Yeah, how else could we have done that? We can make a 4 and 8 too, can't we? So let's just do that over here. Let's say we were going to make that 4 and 8. What would I do? I would do 4 times 2 is 8. 1 times 2 is 2. So 1/4 is equal to 2/8. 2/8 is smaller than 3/8, so we would still get the same answer, wouldn't we? All right, part C. I've got a 2 and a 5. I can't make a 2 a 5, but I can make a 6 a 12 pretty easily. How do I do that? I'm going to multiply it times 2, obviously. So we're going to get 6 times 2 is 12. 2 times 2 is 4. So 4/12 or 5/12? Which one's larger? 5/12 is greater than 4/12. Just a reminder, our mouth is eating the bigger one. Okay, the next one. This one, look, we can make a 2 of 8 or we can make a 3 of 9. Which one do you want to do? I think I want to make this 3 of 9 this time. So I've got to multiply it by something to get a 9 on the bottom. 3 times 3 is 9. 2 times 3 is 6. So 2/3 is the same thing as 6/9, equivalent. 8/9 or 6/9. Which one larger? Which one is larger? Yeah, it's easy to see. 8/9 is greater than 6/9. Moving right along. Told you there's lots of problems today. Yay, this one we don't have to do anything because we got the same number on the top. 3/4 or 3/7. Well, we know the sevenths are smaller pieces than fourths. So 3/4 is greater than 3/7. Okay, now this one, we don't have the same numbers on the top or bottom, so we've got to change them. I can't make a 5 of 12, but I can make a 4 and 8. So how am I going to make a 4 and 8? I've got to multiply something to make that 4 and 8 on top. So 4 times 2 is 8. 5 times 2 is 10. So 8/10 or 8/12, which is bigger? The bigger the number is on the bottom, the bigger the denominator, the smaller the pieces. So tenths would be bigger than 12ths. 8/10 is greater than 8/12. Next one, we don't have the same number, so we've got to change one of them. I can't turn a 3 into a 7, but I can turn a 5 into a 10. So how do I do that? I've got to multiply by something to get a 10 over here. So 5 times 2 is 10. 3 times 2 is 6. We always multiply the same thing on the top and bottom by the same thing. So now we have 6/10 or 7/10. It's easy to see now that 7/10 is greater than 6/10. We've got 2 more pages to work through of problems. You should be able to get them for sure by now. Oh, look at this one. It's tricky. Can I make a 2 and 11? No. Can I make a 3 of 15? Yeah, I can. It's a factor of 15. So I've got to multiply it by something to get a 15 on the bottom over here. 3 times what is 15? 3 times 5 is 15. Got to multiply the top by the same number. 2 times 5 is 10. That is a messy 10, sorry. So now I have 10 fifteenths and 11 fifteenths. Obviously, 11 fifteenths is greater than 10 fifteenths. Next one. I can't make a 3 and 11, but I can make a 4 a 12. How do I make a 4 a 12? I've got to multiply it by something to get a 12. 4 times 3 is 12. 3 times 3 would be 9. So 9/12 and 11/12. Which one's larger? 11/12 is greater than 9/12. All righty, moving right along. Oh, yay, I love it when we have the same number already, either on the top and bottom. It makes it easy. Fourths are smaller than thirds. The bigger the number on the bottom, the smaller the pieces. So 7/3 would be greater than 7/4. And guess what? We're on the last page. And I'm not going to make you do this one, so we only have 2 more to figure out here. All right, compare the fractions below. Doing the same thing. Now, let's forget about the ones for a minute, and let's just look at 1/3 and 2/9, because we know ones are equal. So we got to know if 2/9 or 1/3 is bigger. Can I make a 1 a 2? Yeah. Can also make a 3 a 9. Which one do you want to do? Either way you work it out, you're going to find the same answer. I'm going to make that 3 a 9. How do I do that? Got to multiply it by 3 to get a 9 on the bottom. 3 times 3 is 9. 1 times 3 would be 3. So this one would be equal to 1 3/9, and this is 1 2/9. So 3/9 is bigger than 2/9. 1 3/9 is greater than 1 2/9. Don't let it confuse you when it has the 1 in front of it. Just if you need to mark it out, that's fine, and just look at the fractions and compare them because the ones are equal. So we're looking at 2/3 and 4/7. I can't make a 3 a 7, but I can make a 2 a 4. So I'm going to multiply it by 2 to make it a 4 on top. 3 times 2 is 6. So 1 2/3 would be the same thing as 1 4/6. 1 4/7. Remember, the bigger the number on the bottom, the smaller pieces. So 4/6 would be greater than 4/7. So that problem is 1 4/6 is greater than 1 4/7. Okay, guys, on your assignment today, it's just like all these examples I worked. There's not a problem on your assignment like this. I took that off. You're just trying to get a same number either on the top or bottom to see which fraction's larger. Remember, the bigger the number on the bottom, the smaller the pieces. If you get the same number on the bottom, it's easy to find out because whichever number is bigger on top is the bigger number, right? Okay, so get to work on this. It's a little difficult, but not as hard as it has been the last couple of days, I don't think. I think you'll do well. We'll see you at our Google Meet.